Well, under 3.5, we are supposed to learn how to sketch quadratic inequalities and solve quadratic inequalities. Before we get to example 9, we are supposed to understand a few things that solving quadratic inequalities means we do not specifically looking for a specific value of x. We are looking for a value or a range which satisfies the inequality. So x is not supposed to be a specific single value. It's supposed to be a range. In other words, a range of values are supposed to satisfy that inequality. For example, before we do anything, we need to rearrange the given quadratic inequality so that the right-hand side is equals to 0. Equals to 0. We are going to talk so much about y equals to when you are solving inequalities. Second step, solve the quadratic equation to find the critical values. Of course, we know when we solve a quadratic equation, either graphically or otherwise, we always find the critical values. The values of x when the curve cuts the curve cuts the x-axis. Step number 3, sketch the graph of the quadratic function. After getting the critical values, you're going to sketch how, you're going to know how, and then use your sketch to find the required set of values. And I want us to follow these steps as we solve through example 9. And example 9 is saying 3 minus 5x minus 2x squared is less than 0. We should solve this. Find the values of x for which this particular function is always less than 0. And the one thing that we should always know is that we may decide to work with it that way, or we may decide, since a is negative, we may decide to take everything on the right hand side and have 2x squared plus 5x minus 3 is greater than 0. That way, we are going to talk of something that we are aware of. So when we solve these critical values, first of all, before we rearrange, we have rearranged that is equals to or is greater than. Put this in mind, it's supposed to be greater than. This one gives birth to 2x squared plus 5x minus 3 is equals to 0. And it is that this equation that we are going to solve and find its critical values. And of course, sketch. Now that we have something to do with this, we can solve it using the factorization method or other ways to get the critical values. And if you look at B and AC method, B we have 5, AC we have minus 6. And two numbers, that is simply a positive 6 and a negative 1. So 2x squared plus 6x minus x minus 3 is equals to 0. So 2x is common. We have x plus 3. Okay, minus 1 is common, x plus 3. And this one gives us critical values. If you evaluate this one, x is going to give us minus 3, or x is equals to 2x minus 1 is equals to a 0, and 2x minus 1 being equals to 0, 2x is equals to a 1, and x is equals to a half. And what do we have? These are now the critical values. Okay. Having found out that, we need now to sketch. We have solved the critical values. Sketch the graph of the quadratic function. And if you if you see this one, we are going to draw a sketch to show the shape of the graph and the critical values. And of course, we need to understand uh, since the value of A is supposed to be negative, let us talk of something to do with this. But we have already changed it to positive. You may either want to use this one or this one, but because we have solved using the positive value, then the critical values of x is -0 and a half, -3 rather, and of course a half. Now, if we would wish now to sketch this graph, it is a U-shape. The way it is a U-shape because A is positive. But what are we saying? That we are solving this particular equation. We are solving that particular equation. And we should see for all values that are greater than 0, this particular function makes a lot of sense. When y is greater than 0, this function makes a lot of sense. And you can see that graph, in that region of the graph, all y's are greater than 0. But when are they greater than 0? You can see y is greater than 0 when x is less than -3. I mean, as x approaches negative infinity, y approaches positive infinity. You can see. And this is what is required because we need any range or any solution to be greater than 0. Again, as x is greater than a half, y is always greater than 0 because as x tends to positive infinity, y tends to be positive infinity as well. So you can see these are the values of x, or x lies within this range. For any value of x that is less than -3, y continues to be greater than 0. For any value of x that is greater than a half, y continues to be greater than 0. And that is just how we can use we can use these we can use what? We can use this kind of information to solve the critical to solve the quadratic inequalities. If we had used -2 as the value of A, of course we would have realized a graph that looks like -3 and a half, a graph that is N shape, and you can see we were supposed to have anything less than 0. So we would have taken anything less than 0, you can see, would have taken down the region which is below 0. And if you didn't know, you would have realized the same kind of values. Because for every value of x that is less than -3, then y is less than 0. So as x tends to be negative infinity, y tends to be negative infinity. And for every value of x that is greater than a half, y is always less than 0. So as x tends to be positive infinity, then y tends to be negative infinity. So either way, you would have realized the same kind of value. So don't be afraid of playing around with these numbers. If you don't like working with -a, then you can give it the approach that we gave it. If you are comfortable with -a, then you can continue the way it was originally without interchanging the positions of the terms. All right?